Okay, physics. We need to finish up our notes from Friday. So the vector notes, we are on the last couple of pages. We're looking at those practice problems. It says practice problems, do them on your own to start. So the first one that we're going to look at is number 1. After walking 11 kilometers due north from camp, a hiker then walks 8 kilometers due east. So first off, try this on your own. Try out part A. So pause the video, take a moment, and try it on your own. Okay, so the first thing we want to know is the total distance. So let's draw our picture here. So we go 11 kilometers due north, and then we go 8 kilometers due east. So here's our vector diagram. And for part A, we don't care about vectors. We only care about distance, right? Distance is a scalar. So we're going to solve, and all it is the addition of the two numbers. So our distance should be 19 kilometers. Pretty simple stuff. But part B wants the total displacement. So we are going to go up at an angle to find our resultant, and that's going to be equal to the square root of 11 squared plus 8 squared. Take a moment, solve it on your own, and see what answer you get. And you should get an answer of 13.6 kilometers away from where they started hiking. All right, so that's the first problem. Let's look at number 2 next. All right, so the next one deals with velocities. We want to find the plane's resultant velocity. So this lets us know we're going to be using that Pythagorean theorem to get the length of the resultant. So we got 250 here, kilometers per hour. And then we're going to go due west at 50. So that should be a much smaller vector here, right? About 1/5 the length. 50 kilometers per hour. And here's our resultant. Again, equal to the square root of 250 squared plus 50 squared. So the velocity, 250 squared plus 50 squared, leaves us with, take a moment and solve. Should get you to 55 rounded up kilometers per hour. And there's our answer for number 2. Let's try out number 3. Okay, so number 3 is a little bit more complicated, and so I'm going to draw a picture to start off with. So we have this boat that's going due east on a river that flows due south at 9 meters per second. So here's our river, okay, and our boat here is going to go across the river with 16 meters per second. And I knew to drew the river like this because it says it's going due south with 9 meters a second. Whoops. All right. So if we want to find that resultant velocity, right, we're going to get that 16 into that 9, resultant here. And that should be equal to 18.4 meters per second. Sweet. Answer to number A, or letter A. Part B. But now we're going to start dealing with some kinematics. We know the river is 136 meters wide. Now remember with projectile motion that we are ignoring the vertical velocity because we're only concerned about the horizontal, right? 136 meters is horizontal, and our 16 meters per second is a horizontal velocity. So we want to find our time, and we're given our distance, and we know our velocity. So we can use these 3 to get an equation. Is distance over velocity. take a moment to solve, and you should get 8.5 seconds. Answer for part B. Now that we have our time, remember time isn't concerned with direction, it's the total time that our boat's going to be going across, so it's the total time that our boat's going to be pushed by the river. So if I want to find my distance, I'm going to use that famous equation, distance equals velocity times time, and you should get 76.5 meters. So that's the practice. Notice that the vectors are important, and we get that 18.4, but we never use it in B or C, right? We're using the components of the total velocity to solve for those times and for the vertical distance, or the distance to the south. So now it's time to start considering some higher level of mathematics, and we're going to look at trigonometry. I know trigonometry, it's not your favorite, but we do need to use it for projectile motion because we're moving in two directions. So let's look at this weird symbol. Theta, you might remember, is representative of the angle. Okay. And we then have our hypotenuse, and the hypotenuse is the A to B side. We have our opposite side, and we know it's opposite because it is, opposite of our angle, right? It opens up into that side. We then have and the opposite side is equal to side BC. The adjacent side is right here and is equal to the side AC. And we know it's adjacent because it's right next to, or adjacent to, the angle itself. So how do we relate these different sides? Well, there are some special ratios that are on your calculators, and that's sine and cosine and tangent. Now, no matter the size of your triangle, if the angles of your triangle are consistent, then the ratio between different sides is always going to be the same. Now, what do I mean by ratios? Let's look at sine for a moment. Sine of theta. Now, sine isn't a special equation per se. It's simply a data bank of all of these different ratios between the sides. So if I put in some theta, some angle into my sine function, then what I'm going to get out is actually the ratio between the opposite over the hypotenuse. Now, if this angle, let's say, is 20 degrees, then the opposite over hypotenuse ratio is always going to stay the same. So let's try that out for a moment. Let's plug in sine of 20 into our calculators, and you should find the ratio is 0.34. 0.34. So no matter how big my opposite gets, let's make it 100 just for fun, and we have our hypotenuse here, then this hypotenuse is always going to make it so that we get a ratio of 0.34. So actually, it's going to be 100 over 294, or abouts. If you plug it in the calculator, you'll find that that's a ratio of 0.34. So I can change all of these different sides around, but the ratio between the sides are going to stay consistent. So sine is one of these. The next one is cosine of theta. And this is the ratio between the sides of the adjacent over the hypotenuse. And then last but not least is tangent. And that is the ratio of the sides opposite over adjacent. So if we take a moment to look at all of this, we can see kind of a fun little song, and that others in your math class might have gone over, right? We call it SOHCAHTOA. So there's a song online. You can take a moment to find the SOHCAHTOA song. It might give you nightmares, which in this time of COVID may not be your favorite, but it's SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Things like that can help you remember some of these little bits, right? So we have the so right? And ka, to, a. Okay, those are the different parts of sine, cosine, and tangent. So I'm going to take you through to solve some of these other triangles below. So let's draw our first triangle here. I did not draw this to scale, but that's okay. Let's imagine that this is 30 degrees and that we have a side of 15, and this is side x. So this is the opposite side, and this is the adjacent side, and we have our angle. So if we want to use any of the sine, cosines, and tangents, we want to find the one that, just like in the equations, right, includes the thing we're solving for and has all of the givens needed. So I'm going to use tangent because I have my theta, and I don't know what my opposite side is, but I do know what my adjacent side is. So let's plug it all in. So it's tangent of 30 equals the x side over my 15. And let's rearrange some things. We got to do just a little bit of algebra here. Since I'm dividing by 15, I want to get x all by itself. I'm going to multiply both sides by 15, which leaves me with my value on this side. And when we plug things in, we should get 8.66. Pretty simple. So this is how you solve some of the trigonometry problems. Let's do one more here. So now we have a different triangle. Again, haven't drawn it all that well, but that's okay. I don't have to draw it super accurately. And we have two sides. We have side B and we have side C. So let's solve. Right, so we can do the same thing as before. Notice that we have the adjacent side and side B is the opposite. Side C is the hypotenuse. Let's find side B. So B over 8 equals tangent of 25. I can skip. So B is equal to 8 tangent of 25. And we get 3.73. Now that I have the opposite side, I could do Pythagorean theorem, or I could use another trigonometry function. I'm going to do Pythagorean theorem. So C is going to be equal to the square root of 8 squared plus 3.73 squared. And you should get 8.82. Sweet. All right. So this is how you do some trigonometry and finding different sides of our triangles, which is going to be important because we're going to start now using it to fill in the projectile motion pieces. So I actually want you to do the last page of notes on your own, figure out some of those pieces about the cannon.